Okay, I needed to record and make a couple little bit harder videos for 11.1. Yeah, my daughter kept calling and had an emergency, so I ended up stopping my video at just one example. So here's just more examples for 11.1. Let's do one from the homework that kind of throws people for a loop. What if I have x minus 3 and then e to the negative 7x? Here's my function. Kind of a weird one, right? So we have to find where it equals 0. Well, first we have to do the derivative and where it equals 0. Excuse me, derivative first. So we have to find where it's increasing and decreasing. That's our directions. And if we find a critical value, is it a local min or local max, or does it have any of those? Okay, so what do we always want to start with is the derivative. Okay, and we're asked where or find increasing and decreasing. That's what it's asking. Should write it down a little bit there. Okay, so when we look at this, I have two things that are being times together. What did we have to do if we were timesing two things together? We had to use a product rule. Okay, so I'm going to say the first thing is x minus 3, and the second thing is e to the negative 7x, and then we have to find the derivative of the first. So the derivative of this is just 1, right? Because that is a 1, and the minus 3 goes to 0. The derivative of the second one, when you have e to the x, it's e to the x. But we have something inside, so this was a chain rule. So we have e to the negative 7x, keep it the same, but then times it by the derivative of the inside, which is negative 7. So we'd simplify that to negative 7e to the negative 7x. That's the derivative. So we can't forget to multiply it by the derivative of the exponent. Now the rule says that the derivative is equal to first times the derivative of the second plus second times the derivative of the first, and we just labeled all those. So it's going to equal x minus 3 times this one over here, negative 7e to the negative 7x, plus the second e to the negative 7x times the 1. All right? So then from here, we need to simplify. This needs to be distributed and times by both terms. So e negative 7x, e, whatever this is, times x is going to give me negative 7x e to the negative 7x. Basically, you just add the x in there. Just because you're multiplying, just keep the x in there. Now, if I multiply negative 3 times this, I'm going to get a positive 21e to the negative 7x. Okay, and then over here, I'm going to have 1 times this, which is just itself. And these have exactly the same exponents, and they're both an e. So I have 21 plus 1 more. So I can combine those. And now I have negative 7x e to the negative 7x plus 22e to the negative 7x. Okay, kind of ugly. Then from here, what am I going to do? Well, this is my derivative. And now I have to find where this equals 0 to get those critical values, or where it's undefined. I look at that and I go, how in the world am I going to solve for x, right? If you have an x and exponent, you typically need to use a log. But for this, do you see that you both of them have that ugly e thing? So I'm going to factor that out. So follow me here. So I'm looking for those critical values. I'm going to take out e to the negative 7x. I'll be left with negative 7x plus 22. Okay, so I took that out front, and now I have just that other part left. Now, because these are times, you can look at them each separately. Where do they each equal 0? They're both factors. Where do they each individually equal 0? Where does e to the negative 7x equal 0? Well, to solve that, you would use logs, and you would get no answer because it doesn't equal 0. Okay. E to the 0 power is 1. There's no way to get a 0 out because even if you have a 0 in the exponent, it equals 1. So this actually has no solution. So this did not give me a critical value. It's done. Now, can we solve this one? Sure. Minus the 22 over, divide by the -7, and we have 22 sevens, which is about 3.14. Oh, it almost looks like pi. Okay, there we go. That's our x value. I mean, and so it's our critical value. So we have one critical value. We don't have any undefined. We don't have an x in the denominator. So when we go to look at our sign chart, we're going to put on this 3.14 or 22 sevens, right? And we have to test a value before and after. Well, before we could test, this is 3, we could test 2. So here's our test values. And I am going to put in x equals 2, and I'm going to get out that the derivative at that 2 is going to give me a positive value. Okay, and if I put in the value 4, that derivative at 4 is going to give me a negative value. I didn't calculate them out. Put the number in. Just put it in your calculator. So this is going to go positive, negative, and this is a 0. It's not an undefined. So where are we increasing? We're increasing where you're positive. So we're increasing from negative infinity to our 22 sevens, and we're decreasing from that 22 sevens to infinity. Oops, sorry, it's a little bit low. All right, there you go. This is a local max because you're increasing then decreasing. All right, I'm going to pause this video and maybe I'll make one more hard one here in just a sec.